Alright, hey there students. On this clip we're going to be going over how to use the properties of logarithms for approximation and solving equations. Okay, so right on the title for today's notes, using logarithms, using properties, using uh, using the properties of logarithms, using the properties of logarithms, you can write logs, to approximate and solve. To approximate and solve. Yes. Okay, so that's what we are going to be working on. Alright, so first example, let's write down the instructions first. Use log base 2 of 3, which is approximately 1.5850, and log base 2 of 5, which is approximately 2.3219, to find the approximate value of number 1, log base 2 of 10. Okay, we know this, we know log 3 base 2, log 5 base 2. There's another log that we know that's not given here. What is that? We know log base 2 of 2, which is what? 1. Alright, so keep that in mind. So let's break down 10. Can I write 10 using 3, 5, and 2? One or more combination? Can I? Well, let's break this down. If I break this down, this is simply going to be log base 2 of 5 times 2. Alright? So we know 5, we know 2, so we just plug in the approximate values after using the properties and it should work out, right? So what is multiplication in the log world? So when you multiply numbers in the log world, what you're doing is you're adding, right? Multiplication of numbers is the addition of logarithms. That's why logarithm was invented, right? So that becomes log base 2 of 5 plus what? Log base 2 of 2. Now I can now put in the approximate values. This is approximately log base 2 of 5 is 2.3219, and log base 2 of 2 is 1. And the final approximate result is 3.3219. Alright, so there goes the answer. Alright, let's try another example, approximation example number 2. What if we had the scenario of log base 2 of 3 over 5? So what is division in the log world? Whenever you're dividing, that's the same thing as the inverse of addition, right? Subtraction. That's going to be log base 2 of 3 minus log base 2 of 5. Alright? Now we can put in the approximate values. Log base 2 of 3 is 1.5850 minus log base 2 of 5 is 2.3219. And we can use a calculator to help us with this. It's going to be there you have it, 1.5850 minus 2.3219, and the answer is negative 0.7369. Negative 0.7369. Alright, that's your final result. Okay, How about solving? How can we use properties of logarithms to solve? Number 3, let's solve the equation. Solve log base 3 of x plus log plus 2/3 log base 3 of 27 equals 5/2 log base 3 of 4. Okay? Write that down. Now to do this, first thing we want to do is we want to consolidate these two logs, right? And then we can eliminate. But we need to clean up first, right? I like this log cleaned up, I also like that cleaned up. So let's clean up our logs first before we consolidate. So we want to clean up, we want to consolidate. After we consolidate, just like our debt or credit card, whatever, then we eliminate. Alright? Eliminate. So how do we clean up? See, the coefficient can always become a power. Remember? The coefficient here can always become a power. Because repeated addition is like repeated multiplication in the real world. So, what does that look like? Leave this one alone because it's clean already. Log base 3 plus log base 3 of 27 to the what? 2/3 equals log base 3 of 4 to the 5/2. So what happens when you have a fractional exponent? If you have a fractional exponent, a to the x over y, remember the numerator is the power and the denominator is the root. Okay, so how do we write these two messy logs right here? Just bring this one down, and then you're going to have log base 3 of the third root of 27 raised to the second power equals log base 3 of the square root of 4 raised to the 5th power. Okay? Now let's simplify them a little bit further. Bring this one down. It's already clean. This one, what is the third root of 27? The third root of 27 is 3, right? Because 3 times gives you 27. So log base 3 of 3 squared equals, how about this side? Log base 3, what is the square root of 4? 2 to the 5th power. Alright? Further simplification, bring this down. Log base 3 of x plus log base 3 squared is 9 equals log base 3. 2 to the 5th is 32. If you don't know these, you can use your calculator to expand that. Now that they've been cleaned up, we're going to proceed to consolidate. We need to consolidate the left side because we have two logs there. Alright, so to consolidate this, we're going to have log base 3 of 9 times x, which is 9x. Why on earth did I do that? Because I know when I'm adding logs, it's the same thing as multiplying the numbers, right? Addition of logs is the same thing as multiplying the numbers. So since I have plus, that means it's this times this in the real world. Okay, on the right side equals log base 3 of 32. So how do you get rid of logs? Use exponent, right? The basis of exponentiation will be 3 because the inverse of log is exponent, so that's why we're exponentiating. So put a big 3 on the left side, a big 3 on the right side, and both sides exponentiated. You have log base 3 of 9x, and then here you have log base 3 of 32. Alright, so what does that become? These two cancel out, these two cancel out, and then you have 9x equals 32. Alright, divide both sides by 9, and then you have x equals 32 over 9. Alright, so there goes your final result. Alright, let's try one more example. Not too intense, slightly more intense. Let me clear page because I think I'm going to be running out here. Numerator quadrant, number 4. Number 4, what if we have log base 4 of x minus 2 plus log base 4 of x plus 4 equals log base 4 of 7. Okay? So how do we do this? The logs are clean because you don't have any coefficients in front of them, so all we just need to do here is just consolidate and eliminate, right? Consolidate the logs and then eliminate whatever we have. The logs, okay? So how do we consolidate the left side since we have multiple logs? When you're adding logs, it's the same thing as doing what to the numbers. See this number, this expression here and this expression here? The sum of the logs is the same thing as multiplying those two. So you're going to write log base 4 of x minus 2 times x plus 4 and then log base 4 of 7. Alright? So we're going to distribute and then simplify. Alright, so let's go ahead and do that. So x to the first and second, and then 2 to the first and second. Okay? So we're going to have log base 4. We distribute, we're going to have x squared plus 4x minus 2x minus 8 equals log base 4 of 7. Then simplify further, log base 4 of x squared plus 2x minus 8 equals log base 4 of 7. Now how do we get rid of the logs? Exponentiate both sides using the basis is 4. So you have a 4 here. So put a big 4. A big 4. Log base 4 little. Log base 4 of x squared plus 2x minus 8. And then this one little. Log base 4 of 7. Alright? Since you know exponents and logs are inverses, that means these two will cancel out, and these two will cancel out. And that leaves us with the quadratic equation, x squared plus 2x minus 8 equals 7. So how do we solve this? Set it equal to 0, right? And then we can factor using the x game, if that's possible. So what we do is we add 7 to both sides, add 7, add 7. And that yields x squared plus 2x minus 1 equals 0. Okay. Now let's use the x game on this, see if we can factor that. Set up your x game. AC goes on the top, right? And B goes on the bottom. AC is -1, B is 2. What works here? What works here? Let's see. Well, nothing should work because I messed up. I was supposed to subtract 7 from both sides. That's what I was supposed to do. Subtract 7 from both sides. Sorry about that. That changes this one too. So I'm supposed to subtract 7 from both sides, right? So minus 7, minus 7. This one becomes 15, and that becomes 0, right? So AC is supposed to be -15, not -1. My apologies. Alright, so what works here? 5 and -3. Okay? 5 times -3 is that, 5 minus 3 is that. So that goes in the center. X squared plus 5x minus 3x minus 15 equals 0. Break it down the center, and then we're going to factor by grouping, okay? And then we're going to have x times x plus 5 times x minus 3 times x, and then bring down 15. 15 is times 3 times 5 equals 0. And then from the first two, you take out x. From the second two, alright, let's take that out. So you're going to have x plus 5. And then pull out the minus. Take out 3. And then you have 3 x plus 5 equals 0. Are we looking good? Yeah, these two quantities are the same, right? So we can pull them out, x plus 5 and x plus 5. And x minus 3 equals 0. Now set both factors to 0 and it will solve. So x plus 5 equals 0 and x minus 3 equals 0. And then to solve this, you minus 5 from both sides. Minus 5 minus 5. X equals negative 5. And then this one you add 3, x equals 3. So which of these are answers? Remember, logarithms are always positive, okay? They can never be negative. So this answer right here, this is not a solution. It's not a valid solution. You can only have the positive ones, okay? So our answer is going to be x equals 3. And this thing, okay? So this one, if I plug in negative 5, it will generate a negative answer in one of them. So this is good enough. Okay? So that's that.